Alrighty, on this example, we're going to be looking at midpoints of segments. This one says that B is the midpoint of AC. So that means that this point B bisects segment AC. And bisects means that it cuts it into two congruent segments, or equal. So we know that because B is the midpoint, we know that AB is equal to BC. I put the little congruent tick marks there to show that point B is the midpoint and that AB is equal to BC. So now that I know that, I can do some substitution. I can say, hey, AB is 5x and BC is 3x plus 4. All right, I got everything set up. I just need to do a little bit of algebra and figure out what x is so I can go back and find all the other lengths. So I'll start by getting all my x's on one side. (5x minus 3x), so I have two x's on this side now. 3x and negative 3x canceled out, and I just have the 4 on the right side. I can divide by 2 to figure out what 1x is worth, and x is equal to 2. So I can't stop there. The question asked me to find AB, BC, and AC. So the expression for AB was 5x. And now that I know that x is equal to 2, I can take that and I can plug it back in. So AB was 5x, or 5 times 2. So the length of AB is 10 units. Oops, 10 units, right? Yeah, 10 units. Now, I would expect BC to also be 10 units because B is the midpoint and AB is equal to BC, but let's just check just to make sure. BC's expression was 3x plus 4, and x is worth 2, so BC is equal to 3 times 2 plus 4. 3 times 2 is 6, plus 4 is totally equal to 10. So that's good. That means I probably did it right. And that makes sense that AB and BC are equal. And lastly, I need to find AC. And my segment addition postulate says that AC, the big segment here, is equal to the sum of the segments that form it. So that'll be AB and BC. And you can see you're just going to be adding up the 10s. So AC is equal to 10 plus 10. AC is equal to 20. Cool. So we found AB, we found BC, and we also found AC.